Hi, guys. Okay, so now we are looking at the problems in the chapter on measurements. So starting with the example 1.1, we are trying to figure out, number one, the problem is that the first one is find the volume. A cube is given, one side of the cube is given, which is 0.843 centimeter, and you need to find a volume in centimeter cube. So that's part A. Part B is, suppose this cube is made up of copper. You are given the mass, which is 5.34 grams, and you need to find the density up to 2 decimal places. The first answer A needs to be in 3 decimal places, and the second one B is 2 decimal places. So first of all, always, whenever you're doing these problems, you need to write the formula. You need to write the units after the numbers. Those numbers themselves don't mean anything. And then you need to show the working of all the steps, all these 3. Only then you're going to get the points on the exams. Otherwise, you know, those points get deducted. Okay, so keep this in mind. This is important. All right, next is, so part 1, we are doing the length, width, and the height, that multiplying them, that is a formula to find the volume. And you are given 0.843. So here is 0.843 centimeters times 0.843 centimeters times 0.843 centimeters. Okay, so let's do this. Okay, so here you get 0.599077711, and this is from the calculator. Okay, so we need to get 3 decimal places, or in other words, we need to get 3 significant figures. The question also is saying up to 3 decimal places. You know, technically, when you multiply, if you look at it, 3 significant figures, 3 significant figures, 3 significant figures. So when you multiply, the answer should have the lowest number of significant figures, which in this case is 3. And here's an interesting piece. 0 is less than 5. Therefore, keep 9 as is. Therefore, the answer here becomes volume is equal to 0.599 centimeter cube. Very important to write the unit also. Okay, so that is, so let me just put this here. 3 significant figures, 3 significant figures, and 3 significant figures. So the answer should also have 3 significant figures. Okay, so this is part A. Next is part B, which is, in this case, we need to find the density. Density is mass over volume. Mass over volume. In this case, the mass given to you is in grams, okay, over centimeter cube, because it's a solid. So solids will have centimeter cubes, liquids will have grams per liter, grams per milliliters, you know, depending what we are measuring and what is being asked in the questions. Okay, so grams per centimeter cube, and I'm going to just make this grams per centimeter cube. Okay, so we are given the mass, which is in grams, and this value is 5.34 grams. 5.34 grams. The volume, just now we calculated, we are going to use the same one, 0.599 centimeter cube. Okay, so the density is equal to 5.34 grams, which is the mass, over the volume, 0.599 centimeter cube. So what do you get? Okay, so from the calculator, we have 8.914851. Okay, so we were going to see, this is 3 significant figures, this is 3 significant figures, and here the answer should be 3 significant figures. Okay, now here 4 is less than 5. This is the one we are dropping. Okay, so we are dropping it. So therefore 1 is as is. So we do not change 1 to 2. Okay, so therefore the answer technically should be, because you're dividing this, so this is 8 density is equal to 8.91 grams per centimeter cube. And in the question, they were saying that up to, where did it say? 2 decimal places, 2 decimal places, 2 decimal places. So 3 significant figures and 2 decimal places. Okay, so that's your answer. Okay. So, you know, you will be, so just let me put this here. Okay, so that's 1.1. Now let's look at 1.2. Okay, so now our next problem deals with finding the density. Okay, so this is a simulation problem which cannot be done on the piece of paper here, but I will just show you the 2 ways the density can be determined of a regular solid and an irregular solid. A regular solid has very well-defined sides. So there is a length, there is a width, there is a height. Through that, you can, you measure those with a ruler, and that is going to give you the length, which is in centimeter, times the width also in centimeter, times the height also in centimeter cubes. So for a well-defined solid or a regular solid, you are going to get a volume in centimeter cube. So length times width times height. So that gives you the volume. Now, mass is determined from the weighing machine. So mass comes out in grams. And so when you find the density of this object, you can easily take the grams, divide that by centimeter cube, and you're going to get the density of this object, which is a regular object. But in the case of an irregular solids, what do? You are going to use the method of displacement method, in other words. So displacement, you find it by the displacement method. So what is a displacement method? In a displacement method, we take an irregular solid, which does not have a well-defined sides, and we put this in a graduated cylinder, which has a certain amount of water or liquid. So here is, let's say, a rock. You put the rock in 10 ml of water. That is initially, the initially is this graduated cylinder without the rock. So you read the volume of the water, that is 10 ml. When you add the rock, then the level of the water rises, and now we have a higher value because the regular, the irregular solid or the rock is occupying its own space in this graduated cylinder. So the level of the water rises. So how do we find the volume of the rock is equal to the final volume minus the initial volume? In other words, 15 ml minus the 10 ml. And then here you get 5 ml. So this difference, or 5 ml, is the volume of the rock. So you're going to use this value. You're going to take the rock, place it on the weighing machine, you get the weight. So same thing, you have the density now is equal to mass, which you get in grams, over the volume. The only difference is here the volume is in milliliters and the mass is in grams, because you got it by the displacement of water. So these are the 2 ways you can measure the density of the solids, regular and irregular. Okay. Next, let's look at the next problem. Okay, so now our next problem relates to rounding off to significant figures that are indicated. So the first problem is we need to round up to 2 significant figures. So here, that means that this is not important. So this is going to be dropped off, drop off 0. And oh, sorry, wait a minute. No, even though it is, so we just need to round up to 2 significant figures. So my mistake here. Okay, here. Now we need to, that means just keep this, and this one needs to be dropped off. Now, when you're dropping this off, 4 is less than 5. Therefore, 2 is as is. It is not rounded up. Okay, so the answer in this case is 0.42. Okay, and you leave it as it is. Next is, in this case, we need 3 significant figures. So these will be ignored. This we will keep, and we will keep this, and we will keep this. Okay, so these will be kept. Keep these three, but you drop 6 off, drop off 6, and then 1 also, but 6 is more than 5. So what happens to the remaining 6? Therefore, the other 6, the first one becomes 7. So then your answer is 0. That's the answer now, is 0.0038 and 7. Okay, so you have your 3 significant figures, and you have rounded the number off also as was indicated. Okay, let's look at the next problem. Okay, so I will just do 1 or 2 examples from each of these problems. So here we are adding, and the subtraction, the rules apply the same, which is that the final answer should have the lowest decimal place in the answer. Okay, so we see here that there are 3 decimal place, and there are 2 decimal places. Okay, so that means your answer should have 2 decimal places. Okay, so now let's do this. So these are the 2 numbers you are adding, 2.334, and you're adding it to 0.31. So 4 is just brought as it is, 3 plus 1 is 4, 3 and 3 is 6, and here. But remember, in the final answer, we only need 2 decimal places. So we are just going to keep these 2. Okay, and then of course this number will be there, but 4 needs to be dropped off. So drop off 4. And the remaining 4, because 4 is less than 5, therefore the 4 remains as is, the leftover 4, the retained digit. Okay, so what is the answer? The answer is 2.64. And remember to put the units, milliliters. Okay, the same rule applies to subtraction also. So we will just continue moving on, and if you have any questions, you can always ask. But the next one is on multiplication and division. Let's look at that. Okay, so here in multiplication and division, the final answer should have the lowest significant figure. Okay, so here you're given 2 numbers, 2.334, and you're multiplying it by 0.320. Okay, so what will you do in this case? You're going to first note down how many significant figures are we dealing with in the first one. We're dealing with 4 significant figures, 2.334. The second one has the 3 significant figures. Remember, it's a decimal, so that last 0 is counted. So 3 significant figures. So therefore, your answer should have 3 significant figures in the answer, because the lowest one in the computation had 3. Okay, so let's do the multiplication. Okay, so we see that after multiplication, we get 0.74688. But remember, we only need 3 significant figures. Therefore, we need to keep this, but drop 8 off. 8 is more than 5. So what happens to 6? Then 6 becomes 7. So what does your answer look like? Then your answer, remember, should have only 3 significant figures. So it's 0.747 centimeters. Okay, so always write down the 747 747 centimeter, and remember it's a multiplication, centimeter square. That's the thing. In the addition and subtraction, nothing happened to the units. But when you multiplication, centimeter times centimeters is centimeter square. Okay, but when you divide, then it's those can cancel out. Anyway, so here we have the next problem, 1.6. Let's look at that one. Okay, so here the question is, what is the density of a liquid? The mass is given 31.1415 grams and the volume given is 30.13 centimeter cube. So we know, always write the formula. Density is equal to mass over volume. Okay, the mass is in grams over the volume is in centimeter cube. Okay, so let's just, I always have a habit of writing grams. So grams over centimeter cube. All right. Now you have to just put this. So here, remember, this is a division problem. So in division, again, the lowest, the final answer is going to have the answer will have the lowest significant figures. Okay, so even though the question doesn't ask, but that's, you know, the ideal thing to do. Okay, anyway, so here we have the density 31.1415 grams, always write the units, over 30.13 centimeter cube. And what do you get here? Let's do the math. Okay, so from the calculator we have 1.0, let me put it in here, 1.033571119. Okay, that's 1.033571119. Okay, that is the calculator reading. So here, let's count this. So 1, 2, 3, 4, 5, 6, 6 significant figures. This guy has 1, 2, 3, 4, 4 significant figures. So the answer should have 4 significant figures. So we need to keep this number, and this number. And what are we going to do with 5? We're going to drop off 5. And 3 is, so because it's 5, you know, 5 that is being dropped, and 5 that is being dropped is 5. So therefore 3 is made into 4. Okay, so what do we get here now? So the answer is 1.034, and this is grams per centimeter cube. That's the density, or was it milliliters? But that can also, yeah, centimeter cube and milliliters, the same thing. But here's another thing, yeah, because the question is asking, what is the density of the liquid? Density of the liquid. So even though you are given centimeter cube, this guy is given in centimeter cube, which is fine, but that can also, that the real thing for the liquids is, the real unit for the liquids is milliliters, okay, grams per milliliters, okay. All right, so that's sorry. Okay, so here you are given the density of an irregular solid. No, sorry, you need to find the density of an irregular solid. You're given the mass, which is 51.84, and you are given the initial volume, 17.1 ml, and you're given the final volume. So this is back to what we discussed just now here. So you are given the mass of the rock, you are given the initial volume before you submerge the rock in this container, a graduated cylinder, and then the final volume after the rock was placed in the graduated cylinder. So the final volume is always going to be bigger. So what is the, first of all, the difference? The difference in volume is V final, the final volume, minus the V initial, the initial volume. So here we have 19.8 ml, 1 decimal place, minus 17.1 ml, also 1 decimal place. So the answer should have only 1 decimal place. Okay, so this comes out to be 2.7 ml. Okay, so that is the volume of the rock or the irregular solid. Now the mass is already given, so then just use that. Density is equal to mass. Always write down the formula, even though it looks like, you already know it or whatever. So density is equal to mass over volume. So the mass is 51.842, 51.842 grams over 2.7 milliliters. And that is the density. So here you are dividing. So in the division, we look at the lowest number of significant figures. So this one has 1, 2, 3, 4, 5 significant figures. The lower one has only 2 significant figures. So the answer should have 2 significant figures. Okay. Here we had 1 place, 1 decimal place. And the other one has also 1 decimal place. So the final answer also has 1 decimal place. Okay, so let's do this division. Okay, so when we divide, we get the answer from the calculator, 19.2007407. Okay, so but we only need 2 significant figures. So we are going to drop off 2 and all the numbers after that. But 2 is less than 5. So what happens to 9? 9 remains as is. So therefore, the density of this object is density. The answer is density is 19 grams per milliliters. Okay, 19 grams per milliliters or centimeter cube, because it's a solid, still it's a solid. So centimeter cube. Okay, and there are tables, you can relate to the, you can, refer to the tables and see how close are these numbers to the known, densities. So if it is something, so in this case, it was gold. Okay, in this case, it is the gold that is close to 19. So the object might be gold. Okay, now let's look at another problem. All right, so now we are looking at problem 1.8 using the conversion factor. So we are given the volume of 9.345 quarts, and we need to convert that to liters. So how would we do that? Something that we are going to use is what is already known, and this piece is already known, that 1 quart is 0.94635 liters, and this is the quantity that, equality that either we will give you or you will have to refer to the tables, or you can do the Google searches when you're doing the homework and get it from there. So anyways, so I mean, we're not expecting you to memorize these. So now, but how do we do that? We will be given the whatever entity with the given units, okay, given, then you timed with the conversion factor. Okay, and then that is going to be your answer, and your answer will have the units that you want. Okay, your given units are going to cancel out, and the conversion factor is the one in which the units that you want will be wanted units are going to be on the top on the numerator, the denominator is going to have the units that you want to cancel out or remove. So these two units, so wanted units remain. And see, the other two units cancel out. Okay, so this is how you set up the problem. So let's look at a few things first here. We know that this equality 1 quarts is equal to 0.94635 liters. The conversion factors are 1 quart over 0.94635 liters, or 0.94635 liters over 1 quart. Okay, these are the two conversion factors. Okay, and that the top one is the equality. So these are the two things you would always need to find the unknown or to convert. Okay, so now we are going to write down our given. The given is 9.345 quarts. So write down this here, 9.345 quarts times, now comes the conversion factor. And that conversion factor is, in this case, we need to get rid of the quarts. So this is the guy, you will take the one that has the quarts in the denominator, and you need to convert to liters. So the liters will remain on the top. Okay, now you're going to put in the rest of the numbers. So this is 0.94635 liters over 1 quart. And now here we are going to see that quarts and quarts cancel out. And what are you left? You are left with 9.345 multiplied by 0.94635. Okay, now keep this in mind. This is 4 significant figures, 1, 2, 3, 4 significant figures here. And remember, for the exact numbers, such as this one, you leave out or you ignore. It's not factored in, and here we have 1, 2, 3, 4, 5 significant figures here, 5 significant figures. So your answer should have only 4 significant figures, the lowest number of significant figures. Okay, so in other words, answer should have 4 significant figures. All right, so now what do we get when we multiply the two? Okay, so when you multiply 9.345 with 0.94635, you get 8.8436475. So according to the rules, we only need 1, 2, 3, and 4 significant figures, only these. But this one, the 6, we are dropping off. Okay, 6th is drop off, 6 is more than 5. Therefore, what happens to 3? 3 is converted to 4. So your answer then becomes 8.844 liters. And that's the answer. So always make sure that you write the units, you write the actual number, and show all the steps. Okay, let's look at the next problem, which is 1.9. 1.9. Okay. Okay, so here you see in problem 1.9, we are given 1 ounce of a substance and we need to find the volume in liters. So there is no direct conversion unless you know the density, but we do not know the substance, it's an unknown liquid. Okay, so anyways, we are given the mass, we need to find the volume in liters. So we will have to do a conversion using the equalities. So in this case, there is no direct conversion of ounces to liters, because ounces is a solid, right, is a mass, and liters is a volume. So total different measurements, different quantity, right? So different. So what do we do in this case? So first we are going to take the ounce, which is given ounce, and let's write this down. So given, this is a given ounce, and ounce is converted to quarts, then quarts is converted to liters. So there's no direct conversion of ounces to liters. It has to go through the quarts. So let's write this down. 1.000. Remember, for the decimal, those 3 zeros count. So these all these, so it's a 4 significant figures. So 1.000 ounces times. Now look at the quarts. Quarts and ounces, how are they related? So so we know 32 ounces is equal to 1 quart, and we need to get rid of the quart, and we need to get rid of the ounces. So ounces is going to be in the denominator, and quarts is going to be in the numerator. And we know that 32 ounces is equal to 1 quarts according to the equality. Those are the 2 conversion factors. So that's one piece. Next is, we are going to not stop here because we need to convert the quarts to liters. So quarts need to cancel out and liters will remain on top. So what is the relationship? We know that 1 liter is equal to 1.0567 quarts. Okay, so this quarts and liters are here. The ounces and the quarts, let me put this in a different color. This quarts and this ounce is here. Okay, so these are the 2 conversion factors. And in this case, we see ounces and ounces cancel out, quarts and quarts cancel out. So we are only left with the unit of liters, which is the one that we want. And the rest is just do the math, which means now you're going to take 1.000 times 1 divide by 32 times 1.0567. And here, what do you get? Okay, so when you do the math here, you get the answer 0.0295732. That's from the calculator. But that's not the answer we want, because remember, in the end, it also has to be the answer has to be in the correct number of significant figures. So even if they're not given to you up to what level, you need to get it from your rules when you do the multiplications and the division. So here we see our 4 significant figures. Here there are 2 significant figures, but this is this is a 2 significant figure, but this is an exact number. So, this has to be ruled out. So I'm going to just remove this. And then we have the other one, which is 1, 2, 3, 4, 5. 5 significant figures. Okay, 5 significant figures. So final answer should have 4 significant figures, which means 1, 2, 3, and 4. So we will have to retain these. So we will bring this now here 0.02957. Drop off 3. Okay. And 3 is less than 5, therefore 7 remains as is. All right, so now that's why 0.0295. And that is the standard notation, and this is in liters. This is a standard form, but the same answer can be written in the scientific notation, and scientific notation is 0. So we are going to move this 0.02957, and you move the decimal 1 and 2 places. So now your answer is 2.95 1, 2, 3, 4 into 10 to the power -2 liters. Okay, so that is that is your answer. So just make sure that you make the answer conspicuous, you write down the units, you show all the working, you write down all the details, even though you know how to do it, but that's the way it is. All right, next is, let's look at the next problem. Okay, so here in 1.10, we are talking about Toyota Hybrid, which is using 59.7 gallons of gasoline, and it gives you 1,300 kilometers. Now, the question is, you need to convert this kilometers into miles and the liters into gallons so you can get miles per gallon. So what is the efficiency of this vehicle in miles per gallon? Remember, different units are used in different countries. So we are trying to see how much kilometers per liter of gasoline will translate into miles per gallon in, in another country. Okay, so here we are given these equalities. And these equalities can be used in, conversion factors. Okay, so let's look at the conversion factors because I just want to make sure that, I'm getting this right also. So conversion factors. So here we have 1 kilometer over 0.62137 miles or 0.62137 miles over 1 kilometer, or the next one is 1 liter over 1.0567 quarts, or 1.0567 quarts over 1 liter. Okay, the other one is 1 gallon over 4 quarts, or 4 quarts over 1 gallon. Okay, so these are the conversion factors of these are the equalities which will be given to you, or you can make a note of these in your notes or whatever works for you. Okay, anyway, so here we will write down our given. So it's because it's miles per gallon, the distance per liter. So we will write 1,300 kilometers on top, 1,300 kilometers. So this 1,300 kilometers need to be converted to miles. And we have these liters is 59.7 liters, 59.7 liters, and you convert this into the gallons. And these gallons are, convert that into gallons. So start with the first one, which is 1,300 kilometers over 59.7 liters. Multiply by, let's convert the kilometers, get rid of the kilometers and convert to miles, because there is a direct relationship as we see in the equality. So that conversion factor we are going to use, in which the kilometers are canceling out and the miles remain in the numerator. So here is 0.62137 miles over 1 kilometer. Okay, so that converts the kilometers to miles, but we can continue further because now we need to convert the gallons, the liters to gallons. So there's no direct conversion. We see that the liters need to be converted to quarts, and then the quarts convert to gallons, and gallons need to be in the denominator. So from that perspective, we will have to look at it that 1 liter, so liters will cancel out, and we have the quarts, 1.0567 quarts. Okay, so this way the liters cancel out, so we will have to use this conversion factor. Okay, next is we are going to now get rid of the quarts also. Okay, so next is we have 4 quarts and 1 gallon. Okay, and this is coming from this one. So this conversion factor is used, and this is how we see now kilometers and kilometers cancel out, right? We are left with the miles. Liters and liters cancel out, quarts and quarts cancel out. So all now we are left with is the unit of miles and gallons, and that's what we want, miles per gallon. The rest is just do the math, which is now basically 1,300 multiplied by 0.62137 times 1 times 4 divided by 59.7 times 1 times 1.0567 times 1. Okay, and what do you get here? Okay, so we see after we do these calculations, we get 51.219326. I call this on the calculator. So, you know, even if you have the answer, because it's just, you know, the mileage. So if it is 51 miles per gallon, that is also fine. Two significant figure, or, you know, a little bit of more exact is this. There are three significant figures here. There are 1, 2, 3, 4, 5 significant figures here. There are 1, 2, 3, 4, 5 significant figures here, and the remaining are, you know, the exact numbers. So exact numbers have variable, but out of that also, if you look at it, this one has the lowest, and this is also just 1. These are remaining 1. So kind of like, you know, we can just put it if this could be the answer, or if you are given another choice, 51.20 or 21 miles, this is also fine. So either way, you know, is just fine. Okay, so just make sure that you write the units. Okay, now we are looking at the last parts where we are looking at the conversions of the temperatures. Okay, so if we are given, let's look at it at 1.1, here we are given 80.92 degrees Celsius, and find this, convert it into Kelvin and convert it into Fahrenheit. So how much Kelvin and how much degree Fahrenheit is this? So basically we are taking degrees Celsius, converting into Kelvin, and taking degrees Celsius and converting into Fahrenheit. So one easier method is these formulas. The temperature in Fahrenheit, you can find if you take the temperature in Celsius, multiply by that 1.8 and add 32 to it. That's one thing. The next is you can take the temperature that you found in degrees Celsius, or you have in degrees Celsius, add 273 to it, and that's going to give you the temperature in Kelvin. So let's do that first. So we have 80. So let's do temperature, the Kelvin, Fahrenheit. Sorry, the temperature in Fahrenheit is equal to 1.8 multiplied by 80.92 plus 32. Okay, so let's do the math here. Okay, so the first one is we're taking the degree Fahrenheit and we are converting, we're taking the degree Celsius and we're converting it into Fahrenheit. So we take, first of all, 1.8 times 80.92 degrees Celsius, right? And then plus 32. So here we get 145.65 plus 32. In other words, PEMDAS, please excuse my dear Aunt Sally. So parenthesis, exponential multiplication first, then division, then addition, and then subtraction. That is why you do this first, 1.8 times 80.92, and that gives you 145.65. And then you add 32 to it. And that gives you 177.656, and this becomes 177.7 degrees Fahrenheit. Okay, and that is the answer. So remember that first is when you are multiplying, so you have two significant figures here, and here you have four significant figures. So when you're multiplying, you should have two significant figures, but you know, 145.65, there is no way you can convert it into two significant figures without moving it into the scientific notation. So we will just leave it as it is. Okay, leave you know, as it is. So don't apply the significant figures in this case, okay? But try to keep, like in general, like 1 or 2 places after the decimal. All right, next is the conversion to the degree Kelvin. So what do we do that? So T Kelvin is equal to, you take the Celsius, which is 80.92, 80.92, and you add 273 to it, and this is going to give you 354.07 Kelvin. Okay, and so this piece is this. All right. So that's one thing. And next is conversion from Fahrenheit to Celsius, the same thing. You can just apply this formula. Let's finish it off, 1.12. And here you're given 50 degree Fahrenheit. Okay, 50 degree Fahrenheit, converted to Celsius and then to Kelvin. Okay, so there's no direct conversion of Fahrenheit to Kelvin. So you have to go through this route. So you just write the formula, which is TF minus 32 divided by 1.8, and that is going to give you the temperature in degrees Celsius. Okay, so let's do this one. 50 minus 32, 50 minus 32 divide by 1.8 is equal to T degrees Celsius. Now in this case, how do we do this? Because 50 minus 32 is already on the numerator, right? And 1.8 is the denominator. So we will just do the subtraction and then go from there. Hold on. Okay, so first although it's like the PEMDAS says, you know, that the divisions come first and then the addition and the subtraction, but because this is a part of the, you know, numerator, it's already there, you do this first. So that gives you 18. You have 18 and then you divide by 1.8 and that gives you 10 degrees Celsius. That's the answer. So that's one part. And then the second is convert the 10 degrees Celsius to Kelvin. So we have 10 degrees Celsius plus 273, and that gives you 283 degrees. So for Kelvin, we don't put degrees. So that's another thing. Pay attention to that. Kelvin is just Kelvin, no degrees. Okay. All right. So this finishes all the learning check problems from the chemistry second edition book of OpenStax. And thank you for watching. Take care. Bye-bye.